Hello and welcome to the session. In this session, we'll see how we can construct a ID3 decision tree. This is a question. This is a training data set which is given where we are going to assess the student's performance based upon these attributes. The attributes are CGPA, interactiveness, practical knowledge and communication skills. So finally, based upon these four attributes, you should be able to classify whether the student will get the job offer or not. Yes or no. So let's first rewrite the table here. The table is the same table has been copied here. So first step is you have to calculate the entropy for the target class. The target class is job offer, the last column here. So you have to calculate the entropy for the target class. So the formula for calculating the entropy for the target class is entropy underscore info within brackets target attribute is job offer. So that would be equal to entropy info 7 comma 3, because 7 is the number of yeses 1 2 3 4 5 6 7. So totally 7 data instances are yes and the remaining 3 are no. So 7 comma 3. So the formula for entropy information is minus of 7 divided by 10, where 10 is the total, right? Total number of classes you total number of instances you have, log to the base 2 of 7 by 2 plus 3 by 2 10 log to the base 2 of 3 by 10. So when you calculate this, you get the entropy information as 0.8807. Now let's start with the iteration. In the first iteration, now I am going to see, now first goal is we have to find the root node for our decision tree. So which node I am going to take as the root node? CGPA, interactiveness, practical knowledge or communication skills. Now I can decide which is going to be the root node only after calculating entropy information and information gain for every attribute. For each attribute I have to find these two parameters. So let's first do for attribute CGPA. For CGPA, let's find the entropy information. So write this table first, form the table first. In the table, write CGPA at the first column. What are the different values that you can have for CGPA? You observe that greater than equal to 9, greater than equal to 8, and the other one is less than 8. So you have three different values for CGPA. That means you can, if I choose CGPA as my node or root node, I can do branching based upon these three attributes. So write the three conditions, different values of CGPA. Next, write the target class. The target class is job offer. Job offer is equal to yes as 1, job offer equal to no as the other one. Okay. Now, when CGPA is greater than or equal to 9, how many times you got job offer as yes? See, here I've got job offer as yes 1, and in the here I didn't get. So here 2 and here 3. So 3 job offers as yes. How many times you got no for greater than equal to 9? See here 1, and that's it. You just got 1. So when CGPA is greater than equal to 9, no job offer was only once. Next, let's do for CGPA greater than equal to 8. Greater than equal to 8, I got S here 1, here 2, here 3 and 4. So job offer is 4. Now job offer no, for greater than equal to 8, I got nowhere, right? So for greater than equal to 8, I didn't get job offer equal to no, so you give here 0. Now for less than 8, for CGPA less than 8, observe whether they got job offer or not. So here nothing, right? For less than CGPA 8, nobody got the job offer. So this is 0. For less than 8, how many got job offer? No. So here it is 1, here it is 2. So put 2. So basically how many times I have greater than equal to 9? Total this 3 plus 1 is 4, 4 plus 0 is 4, and so I have 4 students. That means who have greater than equal to 9 CGPA. I have 4 students who have greater than equal to 8 CGPA, and I have 2 students who have less than 8 CGPA. So after constructing this table, don't worry about the last column. You don't have to write it. Leave it. Now we have to find, as I told you, for this attribute we have to calculate entropy information as well as information gain. So entropy information for this attribute CGPA is written as T comma CGPA, where T is the total information, total entropy information. CGPA is because now we are calculating for this CGPA attribute. So what is the formula? We have discussed about these formulas in the last video. Please refer to that video. So entropy information for this one is, you write first do for greater than equal to 9. Okay, for greater than equal to 9, total cases are 4. So 4 divided by total number of entropy information. How many total cases we have? 10. So 4 by 10. In brackets you write minus this one 3 by 4 log of 3 by 4 minus 1 by 4 log of 1 by 4. 3 by 4, this is for the yes job offer yes, this is for job offer no. And please note there is a minus over here. Please remember this. Now the second term is for greater than or equal to CGPA, 8 CGPA. So this will remain the same, right? 4 by 10, because I have 4 cases here for greater than equal to 8 and total cases is 10. 4 by 10 minus 4 by 4, where this 4 is actually for number of job offers. Yes, I have 4 number of job offers which is equal to yes, and this is for the total number. Total number is 8. Log of 4 by 4 minus job offers no is 0. So 0 by 4 log of 0 by 4 plus, now do for the last row. Total number of conditions cases here is 2. So 2 by 10 within brackets minus 0 by 2 log of 0 by 2 minus 2 by 2 log of 2 by 2. Okay, so when you compute this in your calculator, you will get the entropy information for the attribute CGPA as 0.3243. Now you have to calculate the information gain. Information gain, we have discussed these formulas in the last video. You have to subtract the value which you got in step 1 with the value got in this step 2. So 0.8807 minus 0.3243. That means information gain is total entropy information minus the entropy information of the particular attribute. So I am getting gain of CGPA as 0.5564. Now I have to repeat this. I have to again calculate the entropy information and information gain for the attribute interactiveness. Again I have to repeat it for practical knowledge. Again I have to do it for communication skills. For each attribute individual entropy information and communication information gain has to be calculated. So this is what? So this is the next attribute. Okay. So for this attribute first you form the table. So for first column you write the attribute interactiveness. What are the possible values you have? Yes and no. So for S, how many job offers are yes? See here 1, here it is 2, 3, 4, 5. So job offers are 5. How many for yes? How many job offers are no? See here see here. There is one row where when the interactiveness is yes but still job offer is no. So put the job offer as no. Similarly do for interactiveness no. When interactiveness is no, how many job offers are yes? This is 1 and this is 1. So 2 job offers yes, S. When interactiveness is no, how many job offers are no? This is 1, 2, that's it, 2. So what is the total? Just add these two. 5 plus 1 is 6, 2 plus 2 is 4. Now find the entropy information for this attribute. Again 6 is the total number of interactiveness for yes divided by 10, which is the total number of instances that we have in brackets, minus 5 by 6 log of 5 by 6 minus 1 by 6 log of 1 by 6 plus 4 by 10 again because this is a total is 4 minus of 2 by 4 log of 2 by 4 minus 2 by 4 log of 2 by 4. You calculate similarly, you get the entropy information as 0.7896. So how do you calculate the gain? This is the total entropy which I calculated in first step. 0.8807 is the total entropy for the entire training data set minus the entropy for this particular attribute interactiveness. So you're getting the gain as 0.0911. Similarly, repeat for the next attribute, write the table in the similar way, find the entropy information and gain. Similarly, repeat for communication skills. For communication skills attribute, find the entropy information, find the gain. Now after finding the entropy information and information gain for all the 4 attributes, now summarize all of them here. So I have written the, either you can write entropy or you can write gain. So I have just written here gain. So the gain for all the 4 attributes which I calculated in the last few slides, right, that I have listed here. So this is a gain for each attribute. Now based upon this, whichever attribute has minimum gain or minimum entropy or maximum gain, that attribute will be chosen as the best attribute. I've told in the last session, entropy and gain are inversely proportional to each other. Select the attribute which has the maximum gain. So out of these four, CGPA is the maximum attribute with the maximum gain. So that means our first step is now done. So let's choose CGPA as the root node. Okay, so I have chosen CGPA as a root node, and we have seen from the table before, right? In the CGPA, 3 different possible values are there, right? So that means I am going to split the root node CGPA into 3 different branches: greater than 9, equal to 9, greater than equal to 8, and less than 8. So CGPA will be now, root node will be split into 3 branches like this. So then you check, right? When I am having, go back to the table. Okay, the table is here. When I am having greater than equal to 8, here the job offer is S. Here again job offer is yes. Here again job offers are S. So that means whenever I have CGPA greater than equal to 8, always the student is getting the job offer. Now check for less than 8. For less than 8, here it is no, here it is no. So that means you don't have to further branch it, right? So whenever the path is greater than equal to 8, all the path instances are leading to only one, that is job offer is yes. For all the path instances, or for all the CGPA less than 8, all the path instances are classified as job offer is equal to no. But when I have the, so that means what? Greater than equal to 8 and less than 8 will end up as leaf node. Further branching is not required. But when I am having greater than equal to 9, when I am having greater than equal to 9, here I am having job offer as yes, and here I am having yes, here I am having yes, but here I am having yes, here I am having no. So when I am having greater than equal to 9, sometimes I have yes, sometimes I have no. So that means I have to do splitting for the condition greater than equal to 9. Right? So this is a decision tree after the iteration 1. CGPA is our root node. These are the 3 different branches. For less than 8, I get the leaf node as job offer no. This is a leaf node because it's represented as a rectangle. For CGPA greater than equal to 8, I get the leaf node as job offer is equal to yes. This is a leaf node. That's why I've shown it is in the form of a rectangle. But for greater than equal to 9, sometimes there are S, sometimes I have no. So that means you have to write your table again. For greater than equal to 9, take all the other cases. Take all the other attributes, all the 3 different attributes, and what are the job offers. So I have here 3 yes and 1 no. Now based upon this table, I have to do the further splitting of the node. Okay. Now based upon that, now continue the process for the subset of data instances of CGPA greater than equal to 9. So that means this is now coming to iteration 2. Now the same process we have to now continue. Right? I have to now again find the entropy information and information gain for every all these 3 different attributes. So this is what we have, right? For greater than equal to 9, this is a table I'm getting. So for every attribute again, right, I have to now decide which is going to be my next node. Do I choose interactiveness? Do I choose practical knowledge or communication skills? Now that I can choose based upon the gain value. So for every attribute here, I have to find the entropy information and gain, and whichever attribute gives us the maximum gain, that would be my next best attribute. Let's now do for interactiveness. For interactiveness, this is the table that you have to form. From this table, you form this second table. Okay. When interactiveness is yes, job offer how many times yes? 2. See here 1 and this is 2. For interactiveness no, only once. Job offer no is no, you don't have any value, 0. When interactiveness is no, job offer no is 1. When interactiveness is no, job offer yes is only once. So this is a table that you form for the attribute interactiveness. So based upon this table, find the entropy information. Entropy information is minus of 3 by entropy information. What is this? This is the total entropy. Find the total entropy for this entire table. Okay, so that would be 3 by 4 because I have 3 yes and 1 no. This is the entropy information for the complete table. first to do that. Find the entropy information for the complete table. So in this complete table, I have 3 times yes and once no. So entropy information for 3, 1 is minus of 3 by 4 log of 3 by 4 plus 1 by 4 log of 1 by 4. So I am getting the entropy information as this. Now find the entropy information for the attribute interactiveness. So find the entropy information for the attribute interactiveness looking at this blue table. Okay, so total is 2 divided by 4 because there are 4 cases here. Within the brackets, minus 2 by 2 log of 2 by 2 minus 0 by 2 log of 0 by 2. Similarly for the next row, plus 2 by 4 because 2 is the total and 4 is the total number of cases that I have. So 2 by 4 minus 1 by 2 log of 1 by 2 minus 1 by 2 log of 1 by 2. So I am getting the entropy information for this attribute interactiveness as 0.4997. Now find the gain. Gain is nothing but this 0.8108 minus 0.4997, that is 0.3111. So this is the gain for the attribute interactiveness. Now repeat this process. Okay, now repeat the process for practical knowledge. For looking at this table, from this table, the gray table, you come up with this practical knowledge table. So whenever practical knowledge is very good, these are the number of job offers I have got. When it is average, these are the number of job offers I have got, and when it is good, these are the offers I have got. So find the entropy information for practical knowledge. So 2 by 4, because I have totally 2 cases here, 2 by 4 minus 2 by 2 log of 2 by 2 minus 0 by 2 log of 0 by 2. Then plus 1 by 4 because total number of cases here is 1 and total is 4. So 1 by 4 minus 0 by 1 log of 0 by 1 minus 1 by 1 log of 1 by 1 plus again this is the 1 total 1 by 4 minus 1 by 1 log of 1 by 1 minus 0 by 1 log of 0 by 1. I am getting the entropy information as 0 and the gain is, how did I calculate this? The total entropy is 0.8108 minus 0 is nothing but this. So basically entropy information for attribute practical knowledge is 0 and the gain is 0.8108. Now repeat again for the next attribute, that is communication skills, in the same way. So this is the entropy information for communication skills and this is the gain. Now summarize the gain for all the 3 attributes. So for all the 3 attributes, this is the gain that we are getting. So what you can observe here is the maximum gain I am getting for 2 cases here, practical knowledge and communication skills. Both of them have maximum gain. So now which one you choose? You can choose either of this to be the next node. You can choose either of them. Okay, so suppose I choose the practical knowledge as my next node. So this is how I'm going to have my final decision tree. So this is my root node, right, which we have already done the branching for greater than equal to and less than 8. When it was greater than equal to 9, now I am choosing my next node as practical knowledge. You can also choose communication skills. Now when you go back to practical knowledge, there were 3 branches that we could do: good, average and very good. And what we can see from this is, when I chose practical knowledge as good, you always got the job offer as yes. When I chose communications as poor, I always got the job offer as no. And when I chose the communication skills as, no, not this one, sorry, practical knowledge. For practical knowledge, when it is very good, I got the job offer always as yes. When I chose a practical knowledge always as average, I got the job offer as no. When I got it as good, always I got the job offer as yes. So that means it is finally leading us to a leaf node like this. So when it is good, job offer is yes. When it is average, job offer is no. When it is very good, it is yes. So this is our final decision tree. So this is how we can construct the decision tree based upon the entropy information and information gain. So that's it for today's session. Any doubts with regard to this problem, please let me know in the comment box. Thank you so much and please subscribe.